Hello, everyone. My name is Bailey Adams. I am a member of ASABE and also a member of the ASABE YPC, otherwise known as the Young Professionals Community. And today I'll give a brief talk about my research journey as a graduate student. So a brief introduction before I talk about my research. My name is Bailey Adams, like I said, and I'm originally from a small town in north central Iowa, specifically Forest City, Iowa, where I didn't travel too far from my hometown to Iowa State University in pursuit of my undergrad degree within the Department of Agricultural and Biosystems Engineering here at Iowa State University. Just to give a little more context, within this department, I had a special focus on power machinery systems. And furthermore, as I completed my undergrad, I decided to stay right in this department for my graduate studies, where I'm currently a third-year PhD student researching agricultural machinery systems. Some specific highlights from my experiences so far throughout the last 7 years have included a design engineering internship at Hagie Manufacturing, a self-propelled sprayer manufacturer, a unique opportunity to study abroad in Argentina for 2 weeks with an agriculturally focused trip. And furthermore, as I completed my undergraduate degree and transitioned to my graduate experience, I got the opportunity to join the Digital Ag Innovations Research Team, where I currently sit as a member on that team and conduct research with Dr. Matthew Darr and other staff members on the team. So to talk a little bit about my research, I currently do research on self-propelled sprayers, which are technologically advanced agricultural machines that are used to automatically apply chemical products to the crop to help kill off weeds and prevent pests from hindering the maximized crop yields that farmers expect out of their crops at the end of the year. And these machines are really important for the field of precision agriculture nowadays in terms of providing precise chemical application where it is intended, right? And there's really an increasing trend that we're seeing with farmers and custom applicators using the machines. And the trend revolves around operating at faster and faster machine speeds, along with wanting or desiring wider and wider booms so that they can basically cover more area per unit time and increase the overall productivity of the sprayer for what is considered as a relatively narrow spray season most of the time. And with doing that, or with that increasing trend, there's a challenge specifically around boom height stability. And what I mean by that is basically keeping these booms as stable as possible as you travel throughout the field with dynamic conditions, right? The visual up above is a great example of this, where we're traveling at a moderate speed across a terrace, or basically a challenging terrain disturbance, where basically the sprayer disturbance is compounded back to the boom and caused boom height instability, where we made ground contact. And we also have a significant amount of boom height error away from its targeted height above the crop or above the ground. And the issue with boom height error is that, or boom height instability in general, is that as you have unstable booms and they deviate away from their intended position, especially as you travel farther and farther up in the air, there's more of a probability or risk factor associated with wind getting under these booms and carrying chemical throughout the air and causing spray drift, and the spray getting into neighboring fields or neighboring waterways such as rivers and lakes and causing damage. And this is where the importance of my research comes into play. My research is really focused on the vehicle side of the self-propelled sprayers, specifically the chassis suspension system, in terms of providing an optimally performing chassis suspension system or improving the performance of the chassis suspension system in general to increase the stability of the vehicle and therefore increase the stability of the boom, basically to prevent terrain disturbances up front of the vehicle from compounding and reaching the boom and causing boom height instability. And this is where the importance of dynamic systems modeling or virtual engineering comes into play. I conduct research on basically an accurate virtual replica of a self-propelled sprayer to provide valuable insight and directionality behind characteristics of the chassis suspension system that improve its performance and therefore improve boom height stability. So a little bit about my future contribution. As I've worked throughout my graduate degree, I've caught the academic bug where after completion of my PhD, I'd love the opportunity to serve as a faculty member conducting this type of research around agricultural machinery performance and on optimization to increase the overall economic and environmental sustainability of the agricultural industry, and also to teach amazing and diverse students within agricultural and biosystems engineering, and also do service either at my institution or service for professional societies like ASABE. Speaking of that, my ASABE experience has been great so far. As an undergrad, I was involved within the ASABE Student Club at Iowa State University, where I got amazing opportunities to do special events and socialize with other ASABE student members. Specifically, what's depicted there is an amazing trip that sticks out in my mind with the Midwest Regional Rally to Ohio State University at the 2018 MRR. And as I've transitioned the last 3 years into my graduate degree and have really focused on graduate research, I've had the opportunity to continue to serve ASABE in terms of joining the Young Professionals community, or the YPC, as I called out earlier, to give unique experiences and opportunities to ASABE young professionals and graduate students across the world.